Yeah, it's now it's online. Thank you so much, Nikhil. Let me just post this on LinkedIn before we start, real quick. Thank you for for being good sport and allowing me to share that on my LinkedIn. Okay. Um, if you have not joined yesterday, yesterday we basically talked about like the basics of machine learning and basically why we need prediction, why machine learning is taking so much lead in the world of oil and gas industry. Basically because it allows us to model our data and create predictions and forecasting solely based on our data without even telling the model what to do, because the model will learn from our own data, and it will basically reveal the hidden patterns that are sitting in our data. Yeah, that's one of the reasons. This is not the only reason. This is one of the reasons that you should use machine learning for this purpose. Machine learning can be very beneficial, especially for those industries that rely on experimental data, or let's say on the field data, to create models. Quite often in oil and gas industry, uh, whenever a new technology emerges, or let's say a new way of creating cost-effective production or cost-effective analysis emerges, usually there is a need to create a mathematical model to represent that. And we have seen that many years ago, whenever the rate transient analysis started, we have seen some models that started to be generated using material balance, and it was applied for rate transient analysis. We have seen the same thing whenever the boom of shale oil and shale gas has emerged. So what this created the need to create mathematical models that can help you in order to predict the future. But you cannot always rely on those mathematical models to come in early, because some models will just take time, because the process of creating models, or the process of creating mathematical reliable models, actually it will take some time before it starts to come to the technical papers. And you can use machine learning in order to fill that gap before those models do appear. Even those models do appear, you can also use machine learning to do your prediction alongside with your models. So basically what we are saying is machine learning is another powerful tool that you will learn. We are not saying that machine learning is going to replace the conventional analysis. Actually, far from it. We always recommend to use machine learning alongside with those empirical and mechanistic models that we do have exist in oil and gas industry. Now, without further ado, let's go ahead and start the session. So the first thing that we are going to start with is actually the time series analysis. We are going to take some examples on different use cases of time series analysis. We will visit an example of creating classification based on our production data. I will show you another example on how to select one of the best models to do any type of task, which is known as model selection or experiment selection. And a time series is just a piece of chart, or let's say piece of data that flows with time, meaning that we have a single reading per time, and that single reading per unit time, it can be different from one field to another, because some fields they are just operating in basics, or let's say they are operating in minimum cost. So basically they will have daily readings for different reservoir and production parameters and KPIs. These types of readings are usually the production, the reservoir pressure, the PWF, anything that you can think of, which is a performance parameter. This also applies on drilling and monitoring drilling and mud logging in real time. This is also possible. We have, on the other hand, more advanced fields where they have implemented digital oil fields, and basically they are capturing data in high frequency. Let's say they are capturing data in every minute. Maybe they are capturing data in every 10 minutes. At least they are capturing data hourly. So what this will give you a high frequency data in order to start create your models with. Okay. So basically, this is what a time series is. The problem with the time series is not always prediction on those, let's say, on those form of data succeeds, because this data can go indefinitely, and you will not know what's going to happen. Is the data, or let's say, is the production can increase or decrease, or any given parameter? We don't know because these things are unpredictable. The good thing about using machine learning for time series analysis is just another powerful tool that you can use in order to model the predictions on short term. Basically, sometimes in oil and gas operations, we get irregular time series, or let's say interrupted production, or let's say irregular drilling patterns. These types of patterns are usually contains some form of irregularity, and those irregularities, lucky for us, can be captured in machine learning. Machine learning can learn on those irregularities, and it can basically predict how those irregularity will evolve or it will minimize with time, which is one of the most important things to learn if you are actually willing to learn machine learning. um, this is an example of what a time series looks like and different components. If we take a look at this time series actually represents production from a shale gas well located in the United States. And this piece of time series contains a little bit of everything. We have different production patterns. We have interrupted production patterns. We have some irregularities that are sitting in our data. We have some outliers also are also there. Plus, we have some really clean and nice trends, which is something that we are usually looking for, but this is not something that you always find. And plus, we have some cycling effect that is happening in this particular well. Cycling is basically some irregular production that goes up and down in a given time period. Okay, and lucky for us, machine learning can capture all of these patterns and all of these irregularities, and it will generate a forecast for us. So this is what we are going to do in the first example. So let me just show you how we can approach this problem. Okay, please do not feel intimidated if you are not understanding the code, because understanding the code, it requires some basic understanding of Python. If you do not have that understanding, that's just okay. If you join our training, we'll teach you how to understand and utilize Python effectively to create machine learning applications and tasks. Okay, so let's go ahead and start creating our analysis. So the first thing that we are going to do is we need to import a few libraries that are responsible for reading data. So the first library we are going to use is pandas as PD. We have seen this also yesterday. We are going to use matplotlib for plotting. Matplotlib is one of the OG, or let's say one of the oldest libraries out there for plotting purposes, and it's just an easy and intuitive library to use. And we have a machine learning library that we're going to use. It will help us to create our predictions. This library is called stats model. Stats model, the name actually implies that it uses statistical modeling in order to create our forecast, and that's to be honest, that's true. It purely uses statistical approaches in order to solve and find patterns and create forecasts in our data. And from this stats model, we are going to use time series analysis, which is short for TSA. And then we are going to use the auto regression models in order to create our, let's say, modeling object. And basically, this is the line that imports those things for us. Now, the next step for creating such a thing is start reading the data. And we can read the data by creating a variable called well data. We'll start reading off the data because the data is in CSV format. So that's why we're using read CSV. And then we're just going to provide the path for the data. The path for the data is called welldata.csv. And welldata.csv, actually, it sits on my computer. That's why Python will understand where to get it from. Once we do that, we start actually plotting our time series, or let's say our data that we have captured in the field. By the way, the time series can be anything. It can be related to production, to reservoir, to drilling, to operations, to process engineering. It can be related to anything. Okay, so it does not have to be only tied to production. We're going to create a scatter plot. And the scatter plot, we will do two things. So the first thing for the x-axis, I will use the date indexes, which we have the time steps. And for the y-axis, we're going to plot the water production and oil production. So first of all, let's do water production. So well data dot water volume. This is the name of the column. That's why I'm using it. And then we're just going to assign some arbitrary colors to this. For example, usually water is denoted as blue. So let's select the color blue for water. And let's use a marker. Let's set a square marker for this. By the way, this is all optional. You don't have to do. This is just different customization. And let's provide a label for this. Let's call this water unloaded. So this is the water that's being unloaded from the well. Let me show you how these few lines it's going to look like. If I go here and click on run in interactive window, this should run this thing for me. So this is basically how our production is looking like. This is for now, this is only water production. Now let's go ahead and add oil production to this. In order to add oil production to this, what we are going to do is we're just going to copy the same line of code, and then we're just going to paste it because we don't want to waste your valuable time. And the only thing that's going to be different is actually the y-axis for this time. The y-axis this time is going to be oil volume. And let's change a few things. Let's make this as green and make sure that the marker is an upward triangle. This is also possible. And the label, let's call this oil production. By the way, you can just add the units next to that. That's also something that's possible. Let's run this. Now you can see the plot started to show two different series. We have the oil production and we have the gas production, the water production as well. This chart is an interactive chart. It allows you to zoom. You can just zoom on any section of this code if you like to. Now, moving on, since we have plotted all those historical data, the next step would be to train our machine learning model, because machine learning has few fixed steps that we need to go through. The first step is getting the data. We got that, and an optional step would be plotting the data, because plotting the data is so important in oil and gas industry. That's why we did it. But this is an optional step in machine learning. But for oil and gas examples, this is always mandatory. Now, the next thing would be is actually to only train our machine learning on oil data, or let's say on oil rates. This is a decision that is relevant to the domain knowledge, because we know that the production from our water production is usually not predictable easily based on the conventional approaches of decline curve analysis. We have different approaches like water oil ratio predictions, but for now, we're only going to predict the decline curve, or let's say the performance of oil production. But you can apply this to any variable you want. For now, we are going to do only oil. But for next step, you can do water casing pressure, tubing pressure. You can do basically different things. So once you set what data that you want to train on, now it's time to create our training model, or let's say our statistical time series analysis model that it will learn basically from our data. Okay, so let's create the model. Let's call the model AR. AR is a short term for auto-regression. So TSA.ARIMA. ARIMA is an auto-regression moving average model that's basically used for time series analysis, which is something very similar to decline curve analysis that we have in oil and gas industry. But this is a more systematic approach, and it can be generalized and applied to any well you want, or let's say on any drilling operation and any process operation that's happening in the field. Okay, so let's start using our data. Let's only use the first 700 days in our data. Okay, because we are going to keep like 50 days to check if our prediction is working. Okay, and there are few things that we need to set up. For example, the order is basically how do you want the application to behave. These numbers are usually tuned based on your historical data. Once you do the model creation, now it's time to actually to fit the model, because so far at this step the model has not been created yet. Although you created the object in the memory, but the model does not understand what is happening. Now, in order to tell the model what is happening, we're going to do something like model fit. This is our fitted model. So AR dot fit. Now, at this step, model will understand what is happening because it will apply all of these settings on top of our data. Once it does that, it understands how our data is behaving. Okay, so once we do that, now it's time to actually to start predicting values, because now the model knows how to behave. Okay, so for prediction, I will use the variable predict in order to do those, to save the predicted values. By the way, the names of the variables I am using on the right-hand side, on the left-hand side, those are all optional names. You can choose whatever name you want. So model fit dot predict. So using the predict function actually allows you to do predictions based on your historical data. Because so far we have fitted our data and we told the models what setting to do. The next step is actually to do the prediction. Doing prediction, it will recalculate all those points and it will basically apply to the historical data. And then you can compare the historical data against what you have predicted so far. Okay. And once we do that, it's time to actually to start plotting our model. So we will use plt.plot. We want our model to look a linear data, or let's say we want our model to have a line instead of scatter. So that's why we're doing that. And then now we need to provide two things. So the first thing is actually we need to provide is the index. So prediction.index, which is just the number of days on production. So this is what an index means. The second thing we need to provide is actually the prediction itself. And now let's provide some few optional things. So let's call this fitted model. Okay. And then let's give this a nice color. So color, let's give this a nice color of red. Now let's check our work by running this application and just watch for the results. There we go. Now let me just show you or explain what this means. Before I explain what this means, there is a legend that is missing from this plot. Let me show that before we proceed. In order to show the legend, we will use plt legend, and basically this will tell Python to show the legend because it's not existing yet. Let's run this. There we go. Now we have our legend as well. Now let me zoom in to this area. We have three series, or let's say we have three different sets of parameters being plotted. We have those green small dots. I think those dots are really small to view, especially on the screen. So let me just increase the size of these. Let's make the size of 10 and make sure that this is also 10. I think this is going to be a little bit more pleasing to look at. There we go. Now this is what our model is looking like, or our visualization looking like. Let me zoom to the second, to the same place. There we go. Now we have those green dots. Now those are the oil production. We have those blue dots. Those are the water production. Just remember, the water production are there to let you know how the water is behaving. We are not creating any model to predict the water, but you can do that as well. Now, the red line that we have calculated, now this is the model's calculation. This is not our historical data. This is what the model calculated our data to be, and you can see it's fitting nicely on our data. You can see we have few many left green points, and those green points are basically historical data that I have left intentionally in order to test how our model is going to behave on short-term time series analysis. Now, if you want to predict more data, you need to do something called forecasting, because prediction is basically applying what the model learned. You apply that on the historical data. If you want to extend that, this is known as forecasting. Okay, so let's do a simple forecast. Forecasting is just easy because you already have everything already set up. So we will create a forecast equals to model fit, and you can see everything is stemming from model fit because this is our base model. And then dot forecast, and it will ask you how many days of forecast you want to do. Let's do a simple 180 days of forecast. This is too much, by the way, because the time series analysis should be used for short-term forecasting, especially if you have like really, really noisy data. But we are going to do for 100 days forecasting. Let's do PLT and then dot plot. Now it's time to plot our forecasted line. So the x-axis is going to be forecast index because these are the days of forecasting, and it's basically continuing whatever forecast we have from the last production history. This is something that Python will do for you, so you don't need to keep track of that. And the y-axis, or let's say the y value, is going to be forecasted values, and label, let's call this forecast rates. Forecast, for actually, yeah, forecasted rates. We are missing an E. Okay, so looks good. And for the forecast, I would love the forecast to have the color of black. Okay, now let's run this piece of code and see how our model is performing. So let's run this. There we go. Now we have managed to generate forecast effectively. And you can see on the short term, the forecast is basically fitting nicely in our data. If you want to optimize this forecast better, what you need to do is you need to optimize those parameters. And those parameters optimization can actually demand some time. But basically, initially, the first 20 days in our model looks fitted very perfectly. And the problem with this data is actually irregular production from shale gas. So that's why the data is not very smooth. You can use these types of time series analysis for these types of data sets, no problem. Usually, typical decline curve analysis fail in these types of data because decline curve analysis requires a steady production with no interruption and with no manipulation of production rates. Yeah, so this was the first example that's basically was talking about the irregular production and how we can use time series analysis in order to forecast that. Basically, if you want to export the forecasted values, that's very simple. So let me show you how these forecasted values are looking like. So if we type in the console forecast and then print enter, and you can see now this is the forecast that the software has generated. You can copy this to Excel, you can copy and send this to your colleague, you can do whatever you want with this, because now this is the information that you acquired from training your model. And if we go ahead and count the effective lines that go through creating the model, actually the effective lines are only four. Those are the four only lines that are responsible for the model. Everything else is just basically some pure Python code that's telling the software to do some particular plotting task. So under 16 lines of code, we have, and in less than 20 minutes, we have managed to create a time series analysis, a basic one, but we have managed to create a time series analysis for a shale production data. Now, this is the first example. Let me show you another example that is regarding classification. Okay, but before we go ahead and show you that, let me show you what a classification does mean. A classification is basically whenever you have a particular data set, and that particular data set, sometimes you see some data points, or let's say some wells and some operational points are basically sticking together and they are forming something similar to a group. And in order to classify those things, what we need to do, we need to use clustering, or sorry, we need to use classification models. we have many models that we can use for classification. We have logistic, we have decision tree, we have support vector machines. Basically, we have lots and lots of models that we can utilize. One of those famous models is known as support vector classification. So let me show you how to do an example of classifying different production for different wells based on the labels and the values for those wells. So let me show you where the data is coming from. So basically, this is the data. We have different production data, and the most important thing is those data are labeled. We have labels on those data. We have some wells are denoted as okay production, some wells are a high in production, some wells are low in production. So let me just import this data and show you how this data is going to look like once it's printed nicely on the screen. So in order to do to go through the same thing, we need to, of course, we need few libraries that we have already seen. So let me just copy those libraries. And we have already seen pandas. We have already seen matplotlib. The only library that we have not seen yet, which is called sklearn support vector machine. This library will basically allow us to create a classification based on our oil and gas data. Okay, so let's start reading off the data. So pd.read CSV, because it's a CSV file. If it's another different file type, we can have different functions for that as well. So the file is called lab production.csv. And then let me show you just to print out how the file is looking like. There we go. Now these are the production from our files, or let's say these are the field values. We can see there are labels on those data, and those labels are basically classifying how these wells are performing, okay, at this particular time step. Now, next step is actually to create the predictive model. Creating predictive model for regression and for classification is much easier than time series analysis. Let's create a support vector classifier, and it's going to be SVC. This is the name of the class that will create classification for us. Basically, this is the only thing that you need to do. Next thing is actually we need to define the data that actually the model will predict, and or let's say the model will be trained on. And basically, we have few columns that I want the model to work on and understand and basically create predictions for me. So the first column that I want the model to understand and create classification based on that data, it's actually gas volume. The second thing is actually the water volume. And you can add different things to this. Okay, now these are the values that the model is going to learn based on. The next thing is actually to fit the class, or let's say to fit the model. In order to fit the model, we will call the model and then we will type fit. And this provides two inputs. The first input is actually the x-axis, how to train the model, and the y-axis, how to compare the results of the model. The y-axis is basically coming from those labels because we want to predict the types of wells whenever we provide different values for the wells. So the values for the wells, or let's say the classes of the wells, can be okay, high production, and low production. So in the future, whenever I provide different gas and water production, this machine learning piece of code must be able to classify this well for me into one of those three categories. You can have as many categories as you want, but for this example, we have decided to have three categories only. The categories are sitting in a column called labels. That's why we're using its name. Now, just out of curiosity, let's just run the model and let's see how this is looking like. Let's run this, and it says that the water volume is not correct. Yes, because we are misspelling that. Let's run this again, and there you go. You can see you have this nice green arrow, meaning that this is just working fine. Okay. Now, the next step would be actually to create the values, or let's say the data for this model, and just start plotting these. So in order to start plotting these, I will plot the data on a scatter plot. Usually classifications and regressions are done on scatter, and then the models are just plotted as a solid line. So the x-axis will be data frame dot gas volume. This is going to be a scatter plot. The y-axis is going to be the water volume. And let's make the color of these as a black. For now, let's give this a nice size of 50. So it's going to be a little bit on the bigger side. And let's provide an edge color of those to be red. So it's going to pop a little bit better. So let's run this code. There we go. Now those are our scatter plot. And this is how our plot is looking like. And please do not forget that on the x-axis, we have the gas volume, and on the y-axis, we have the water volume. We can have that setting, no problem. That's just something easy to do. So let me just show you. So X label, it's going to be gas. The Y label, it's going to be water. You can have as sophisticated as label as you want, but this is the basics of it. Okay, so once we have those, the model is already creating a prediction, but I am not plotting that prediction. Why is that? Because I am not deciding to plot that manually. So let me tell you what the model will do. The model will read all of these gas and water production. It will basically create a boundary for these data. So let me show you how the boundary is going to look like. So let me just take a snapshot. Once the model learns on your data, it will just start classifying your data. It will tell you like this region is a good performing well. For example, this region is an okay performing wells. And this is going to be like low productivity or something similar to that, depending on the labels that you have just provided. Now, how can we create this? This is basically very simple to create because we already have libraries and classes that can do that for us without us writing those codes explicitly. So in order to do that, we're going to do inspection dot decision boundary display. This will allow the software to show us how those different decisions are being made if this well is okay and this is not. But basically, this does not only apply to wells. This can be applied on pumps, on separators. It can be applied on any piece of equipment in the oil and gas industry. By the way, it can also apply on the soft skills and employee performance as well. This is something that's so general and so elastic. You can apply basically on everything. Hopefully, you're not getting bored so far. So we are going to pass our support vectors because this is the thing that we are doing. And then we are providing our data. And then we are just going to tell it that I want color of rainbow. So I want the rainbow color matching. So let's call this rainbow. Rainbow color is so dominant in oil and gas applications. We have already seen that. And let's provide a transparency of 0.5. So let's run our application. It says it does not have a CMAP. Yeah, for some reason, it's saying that it does not have a CMAP. Dot from estimator. So let's run this again. There we go. Now this is our decision boundary and how our classification is working. Basically, it classified our application into 3 different areas. And once you see this plot, you will understand how your wells are performing and how different wells actually belong to different categories. And each particular region is going to be held for a particular performance category. The only thing missing from our application is actually the labels of those plots. So let me just create the labels for those. So let me just paste this real quick because we are actually running out of time. So let me show you how this is going to look like. I'm just adding text to this, by the way. So let's run this. There we go. Now you can see we have different well names also appearing on the screen. Once you start using this created model, now you can actually start giving new values of oil and gas production. And once it does that, it will start projecting where this well is going to perform. It can actually fall in here or in here or in here, depending on. Once it falls at particular location, it will tell you that this well is performing good or performing bad. It basically answers something similar to ChatGPT that this well is okay, but the labels and the categories are already predefined in your data. Now, this was the second example. I know we're going fast through the examples, but I just want to show you as much as possible. In machine learning, there are lots and lots of applications. There are lots and lots of models. We get new models coming out yearly, and this basically compiles a huge list of models for us. Sometimes we do not have enough time to know which model is best for us. We cannot just go ahead and try out everything. So for this purpose, people have noticed this weakness in machine learning, which is the lack of time. We don't have enough time to basically try out each and every model. So what they did a very smart move. They created a library that will allow you to test all the models at the same time without even creating those models. So in this example, I will show you how to check if your data is fitting one of the models better than the other. Just follow the example. So the first thing that we're going to do is we are going to import a library called PyCaret. PyCaret is the library that will show you the experiment and basically how to compare different models to each another. By the way, this is one of the things that we covered towards the end of the training because it requires some basic understanding of how those models are working. And the next thing, we're going to import pandas as PD because this is going to be used in order to read the data. So let's read off the data basically from this. Let me copy this, paste it. We already have that. Now, the next step is actually to create an experiment to know which model is best fitting our data. So experiment, or let's call this XP, equals to PCC dot experiment classification experiment. So basically, we're creating an experiment to know which model is fitting best. Okay, so basically, this is a part of optimization of machine learning operations. The next thing is actually to create the values that we want our model to basically classify our data on. And we can have any column we want. For this example, I will be using the same columns as we did earlier. So gas volume, water volume. And basically, this is it. Now we need to move forward and start implementing the experiment. So experiment dot setup, we are setting up the experiment. Our data is X. The target for this experiment is actually the labels. If you do remember, we have the labels column that it contains all the labels that we're classifying the well. So let me show you. This is the label. This is the target for our classification. And let's just provide a session ID. By the way, session ID is something optional. Just this is just a random number, so you can keep track of different experiments. Now, once we have that, the only thing remains is actually to compare the models. So once you compare the models, basically you're done. It will basically show you the best models performing from the best performing to worst performing. Now let's me run this application. It will take a few seconds to load up. So let's run this. You can see now it started to load up. It says in target. So let's see why it's not targeting our data. I think we are misspelling something. It's called labels. The target also called labels. For some reason, it's not detecting. Yeah, so let's add the labels as well because we are actually omitting the labels. Let's add the labels as well. Now let's run this. There we go. Now the model has started to set up itself. Those are basically some setup parameters that we don't care about. Now the model is actually showing a processing bar. A processing bar is basically what it does. It will take all of these data and it will basically apply it to each and every machine learning model that's used for classification. And it's already programmed and it's already there. Once the progress proceeds, you can see that your data is being fitted on top of all the machine learnings, and basically you will get the best performing models from that particular process. So let's just wait for a couple of seconds before the models start to spit out data. Now the model has started to generate some comparison for us, and the model is still processing. By the way, this is something that you usually do whenever you don't have a clue which model is basically going to work best on your data. So what you will do like a blind testing on the models. And you can see we have close to 12 or 13 models that's already applied in our data in less than 1 minute. And you can see like we have the top models that are highlighted in yellow, and we can select any of those models because the accuracy on those models are 92%. So it's basically it's pretty close to each another. This is another part of machine learning that we usually teach in the training, which is how to select the best model based on your data without even sweating or shedding a sweat. So this actually takes us to the end of today's session. Uh, this was a 2-day series of workshop on how to utilize machine learning and apply it to oil and gas data. Thank you so much for attending.